our derivative, again, needing to have both the input and the output. Now, I said that we could really, oops, no, it says an equation of the tangent point. Okay, so how do I get the function of the tangent line? I need to know the slope and a point. I've got the point. Okay, I say which one, but because we need both the x and the y of the point, we'll say the point is the 0.81. So the slope of the tangent is going to be -1 to the 1/3 divided by 8 1/3. What's the cube root of 8? 2. So it's the slope is -1/2. The equation would be y equals -1/2 x minus 8 plus 1. Okay. So we have y equals -1/2. Let's see, this is going to be plus 4. It's next there. Plus 4 plus 1. Okay. Now again, I'm trying to move through this so we can get to section 3.7 yet. And so my next thing I would love to do is say, let's get on the inspires and let's try them out. Let's, put that equation in. However, I cannot have you put this in as f1 of x. We have to go back and we'd have to write this as, let's see, y to the 2/3 equals 5 minus x to the 2/3. So y equals 5 minus x to the 2/3 to the, what power? 3/2. Please do not be tempted to say, oh, that means it's 5 to the 3/2 minus x. You can't distribute the exponent, remember? We all think of doing it, but we always stop ourselves, hopefully, and say, no, you can't do that. And so you'd have to put this in. Now, what happens is that this appears to be just a straight function here, but this means we have the square root of this whole quantity. And if we're taking the square root, there's really a plus or minus that comes in play here. And so that's how we get both pieces of that. Okay. So we could take it, but if you're going to take the derivative of that, you got to take the derivative of both pieces. This way we don't have to do that on it. Okay, now remember, we go through these quickly in class. There's no way that you actually understand this problem on your own. Until what? Until you do it on your own. Yeah, later on. Okay. Let's see. Find two circles. Oh, this is a good problem. These are the types of problems that I want you to have. And it's so easy just to give you practice problems that are simple. But these are the ones that really test our understanding of all the mathematics we've ever had. So let's see here. Two circles, radius 4, tangent to the graph of y squared equals 4x. At the point 1, 2, find the equations of these two circles. Well, first of all, if I'm going to have something tangent to the graph of y squared equals 4x, I can't put that in the inspire unless I do what? Yeah. So I'm going to have to put in actually two functions. Y is plus or minus the square root of 4x, which means that we put in y equals plus or minus 2 square root x. So let's do this one because we really do need to get a picture of this. So take your inspires, go to a graph page, and let's put in 2 the square root of x, and let's put in -2 the square root of x. Whoops, let's get another, there we go. -2 square root of x. Okay, so if we put both of those on the same one, we're going to be able to see that, that whole function, or not a function, but equation. Now, we want to have two circles. The circles have radius 4. Okay, so identical circles, same radius. these circles are tangent to this graph, okay, at the point 1, 2. Well, let's put a point on here. That will help us then. We'll put a point on, and we're going to put a point on at 1, 2. So make sure you have that. There we go, at point 1, 2. So we want two circles. We want one up here that's tangent to this point, and we want one down here that's also tangent to that curve at that point. Got it, James?
Yeah, I got it.
Got it visualized?
Yeah,
Okay. Now, if I want to have a circle tangent to a curve, what does calculus have to do with that? James? I'll ask my question again. Okay. If I have a circle, whoops, get those out of the way. If I have a circle tangent to this curve at this point, what's calculus got to do with that?
Well, you're using a kind of like derivative of it.
Derivative of what?
Of the correct like curve.
Okay, so the sideways, the inverse function of the parabola is what we really have here. Okay, so if I take the derivative of this, continue.
I'm not really sure how to come back to that.
Okay. You see, this is like any problem in life. Have I ever told you what a true problem is? A true problem is something that you don't already have an answer to. Do you have an answer to this one yet? This problem? Anyone happen to know already what this is? No. Okay. So a true problem, we don't have an answer to the question that's posed. We also don't have any clue as to how to get to the answer. That's a true problem. If you think back to things in your life, when you're really, really stumped and frustrated is when you don't have an answer and you don't have a clue how to go out and get an answer. Okay, so what do? You start searching for things you know related to the problem. Some of them are going to work and some of them aren't. But you keep searching until you find those things. So you said take the derivative. Okay, let's go with that. If I take the derivative of this function, what does the derivative tell me? Emma, you had a suggestion.
It tells you the tangents, like the actual line of tangency at that point.
Does it tell you the line of tangency?
Yeah, that's what the slope.
Okay, it tells you the slope of the line of tangency. Now remember, I've got a circle sitting up here. I now have a tangent line, but I know the slope of that tangent line. Yeah, Casey.
You have to find the slope of the line that would be perpendicular to your tangent line.
And the line that's perpendicular to the tangent line relates to the circle in what way?
It is going to point you directly to the center of the circle.
Because we know from geometry that any radii drawn to a line tangent to the circle is perpendicular to that tangent line. Remember that? Man, that's reaching back a ways, isn't it? But that's exactly what we've got here. So if we've got a circle and we've got a radii drawn and we have a tangent line to that, we know that those two lines are perpendicular. If we know the slope of this line, the tangent line, then what do you know about the slope of the radii? Negative reciprocal. Okay? If you know the negative reciprocal, then you know the slope of this, what are we trying to find? Equation of the circle. Okay? If you know the slope, how is knowing the slope of this going to help you? So we're not there yet. If you know the slope of that radii, so now you've got to think back. What would this, and by the way, the radii is 4. Okay? You're trying to find the equation of a circle. What does the equation of a circle look like? X minus what?
Y.
Because I'm asking you? No. Not y. Okay, so how about x minus h quantity squared plus y minus k quantity squared equals r squared? Yeah. Okay. Yeah. Honestly, yeah, I mean, this course, have I told you before, you know all the math you need to know for this course? Yeah. The hardest thing now is just remembering that you know it. Going back to all those courses. So now you know the equation that you need to get to. Do we know the radius? It's given to us, right? That's 4. So this would be 4 squared. Now, what about h and k? H and k represent what? Center of the circle. So we know that the center of the circle is going to be h and k. Now, okay, let's put all the pieces together now. We use the derivative to find what? Slope of the tangent, and that helped us to find what? Slope of the, okay, which is the radius, slope of the, okay. And because we know the slope of the radius of this, do we know this right here? It's what? 1, 2. We need to find h and k. So how are we going to find h and k? Well, I know that I could put, let's see here. I know that if this point is 1 and 2, let's see here. Remember my pathway here. You guys keep thinking. Let's pause this just a little bit while we're doing our thing. Yes, James. Could I, that's a good idea. Distance formula. Distance equals what?
The square root of the quantity x plus 2 minus x plus 1 squared plus y plus 2.
I just took away some of those sums, but same thing. Okay, James. Now what?
You can plug in 4.
The length of the radius. Okay. You're on to something. Yeah, Emma?
Yeah.
Oh, okay. Thought you had an idea there. Casey?
Could you square both sides?
I could. I still got 2 unknowns though. But I could do that. Oh, I'm giving you a hint maybe? Yes, Becca.
Can't you just take the derivative and find the slope of the line?
I did that. That was the first thing we talked about, was taking the derivative of this.
But then don't you have the equation of the line, so then you
Okay, so I have the equation of the tangent line, but what I need to do is find h and k. And so this would be like h and k. The x and the y here would be like h and k. Well, I'll tell you what. I've got a problem because I have 2 unknowns in only one equation. Any way I can substitute something in for one of those? Yes. Lindsay. Time? Oh, that's